Hi, this is Kavita Suresh Kumar, and in this video I am going to demonstrate how to create S3 Bucket and DynamoDB together in AWS using Crossplane Composition. I have logged into the AWS Management Console. First, let us validate whether we have any DynamoDB table or the S3 Bucket in this account. Click the DynamoDB, click the tables. So we don't have any table in this DynamoDB account in the US East 1 region. Now click the S3 bucket here. Click this. Click the buckets. And we could see that we don't have any buckets. We are going to create the S3 bucket and the DynamoDB table using the Crossplane. For that, we need the AWS provider installed in Crossplane. First, let's validate that. kubectl get providers. So we could see the outbound provider AWS is installed and it is healthy. We need to create composition now. So composition is a template, so in which we are going to specify what are the resources we wanted to create when we use that composition. First, let's create the composition YAML file. Since we are going to create both DynamoDB and S3, so I am naming the file as dynamodb-s3.yaml. First, we need to provide the API version, which is going to be API extensions.crossplane.io/v1. Next, we need to provide the kind. The kind is going to be composition. And then we'll give the metadata. As part of the metadata, we need to give the name. So we will give the composition name as DynamoDB-S3. Then we'll give the spec. So in the spec, first we need to give the composite type ref. So this is where we are going to specify which composite resource creation we will be using this template to create the resources. So there we need to give the API version, so which is going to be api.example.org, and then we need to give the version, which is going to be v1 alpha 1. Then we need to give the kind, which is the database. Now let us define the resources. So first we will define the S3 bucket. So I am going to call as S3 bucket itself. And then we need to give the base, and as part of the base we need to give the complete definition for the S3 bucket. So it's going to be S3. API version is going to be s3.aws.outbound.io/v1 beta 1. Then the kind is going to be bucket meta data name. We'll give the name as cp-bucket. Then the spec we need to give us for provider, and then the region US East 1. And then we'll give the provider config ref. So we are going to give the name for that is default. So now we have defined the S3 bucket. Now let us go and add the DynamoDB. So we need to give the base, API version. This is going to be dynamodb.aws.outbound.io/v1 beta 1, and then the kind is going to be table Then the metadata, we need to give the name. I'm going to call it as cp-database. Then we need to give the spec for provider, to give the region US East 1, and then we need to give the write capacity. Then we need to give the read capacity. Then we will need to give a attribute. Name, we will give it as S3 ID. Type S. Then we'll assign that to hash key. Okay, so now we have added the necessary information for creating the composition. Let's save it, and then let's create the composition. kubectl, the composition has been successfully created. Let's validate that. Yeah, we could see we have created a composition DynamoDB -S3. Now let us create the composite resource definition. So it is generally called as XRD, so I'm just giving that in the name. First we need to give the API version. It's going to be the API extensions dot crossplane dot io/v1. Then the kind, which is going to be composite resource definition. Then we'll provide the metadata. We need to provide the name. The name is going to be the plural, the kind, and then the group api.example.org. Then let's define the spec. The spec, first we need to give the group, which is going to be api.example.org. Then we need to give the names. Here we need to give the kind, which is going to be database, and then the plural is databases. Then we need to give the versions. We need to give the name v1 alpha 1. Then we need to give us served is true, because it is available for use. Then we need to give the referenceable as true. Then schema is going to be open API v3 schema, and then we need to specify the type, which is object. Properties, spec, type, object, properties, region, type, string, one off. Then we are going to specify the pattern. It can be either US or EU pattern. Then we need to specify which field is required. That is going to be region. then we are going to specify the claim names. So if you want to create this any custom resource as part of the namespace, you should use the claim name. So we are going to call this custom database, plural as custom databases. Okay, so successfully we have added the necessary information for creating this composite resource definitions. Let's save this, and now let's apply this change. So we have successfully created the composite resource definition. Let's validate that. Yeah, we could see it is established as true and offered is also true. So now let us create a custom resource. cr.yaml. So here again, first we need to provide the API version. So here the API version is going to be api.example.org/v1 alpha1. Then we need to give the kind. So kind is going to be the database, and then the metadata. So here we will provide the name. This is the name which will be used to create those resources. So I am going to call it as the DB S3 Composite, and the spec, and we need to provide the region because this is a mandatory field, right? So I'm going to give it as US. Save this composite resource. Now let's create the composite resource now. kubectl apply -f. We have successfully created the composite resource. So let's validate that. kubectl get composite. So we could see that we have successfully created it. It is synced, but it is not ready. So let's get the resource information. kubectl get managed, because this composite it is going to create two managed resources. One is the bucket, the other one is a table. So we could see that there are two managed resources, the table and the bucket has been created, right? So now let's go and validate that in the UI. So already we are there, the S3. Let's refresh. So we could see there is a new S3 bucket created using the name what we provided, DB S3 Composite. So now let's go and check whether do we have any DynamoDB table created. Click DynamoDB, click tables. We could see there is a DynamoDB table also got created. So we created two resources now. See, the advantage of using the Crossplane to create these two resources is, one is we are using the declarative form of definition for creating these resources. The second one is Crossplane uses the similar Kubernetes concepts. So because of that, it will be keep on the provider controllers will be keep on monitoring the resources created, and if they find any change, for example, currently we see this DynamoDB table created. So what I'm going to do is, I'm in the console, I'm just clicking it and I'm deleting it. So I am going to delete this table which was created by the Crossplane, right? So this will disappear. But since we have used the Crossplane to create this resource, so it will be, if you go and check it in the Crossplane, right? So if you go here and if you look for the kubectl get managed, So here, when you use the kubectl get manage command, still you are seeing those two resources, the bucket and the table, right? So it uses a specific interval. It keeps on pulling the external resources to see whether there is any change in the external resource. So in our case, what we did is we actually deleted the table, right? So now if you go and see in the UI, you'll see there is no table exist. Let's refresh. Yeah, so there is no table exist. So what Crossplane is going to do is, after a certain interval, when it polls for this information, if it sees there is no table exist, it is going to recreate the table again. So that is the advantage of using the Crossplane. So it ensures always the desired state, what you have given in the configuration, is maintained. So now let us go to the terminal and describe the table information. kubectl describe. So we could see that these are the different conditions: when is the last transition date, when is the last incorporation. So all these informations you are able to see here. So you can see that it is the external resource what got created 4 minutes 49 seconds. Now let us monitor in the UI whether the new table has got created or not. Now we could see the table has been successfully recreated. This here you can see about the last transition time and the reasons, and here you can see last transition time is like 11:35. Actually, when it was first created, it was 11:25, right? And then you can see that the age of the table currently it is 28 seconds, right? So this is the advantage of creating the resources using the Crossplane. So now let us see how we will be able to delete these resources. kubectl get composite. So this is the composite. So we will delete the composite. Delete. Set. So the composite has been successfully deleted. Let's confirm that. kubectl get composite. Okay, so let's go and validate that in the UI as well. Let's refresh it. So we could see that table has been successfully deleted. Let's validate the S3 bucket. Click buckets. So we could see that the bucket also has been successfully deleted. Now let us see how we can create a claim. For that, first we need to create a namespace. Create space, we'll call it as demo. So we have created a namespace demo. Now let us add the definition for the claim. S3 claim.yaml. First we need to give it the API version, which is going to be api.example.org/v1 alpha1. Then the kind is going to be custom-database, and then we'll give the metadata name. We will give it as DynamoDB-S3-claim. Along with the name, we need to give the namespace name also. So we'll give it as demo, and then we need to give the spec, and here we need to specify the region, which is mandatory. Okay, so now we have added all the information for creating a claim. Let's save this. Now let us create this claim. kubectl apply setf. So we have successfully created the claim. So let's validate that. kubectl get claim. Because we have created a claim in a different namespace, we won't find it here. So let's provide the namespace name as well. Okay, or we'll give A, so it will get the information from all the namespaces. Yes, we are able to see that. Right. Now let us see the resources which it has created. kubectl get managed So we could see it has created one table under the bucket. So let us go and review that in the UI also. Right, let's refresh here. So we could see here it has created the S3 bucket. Now let us go and validate the DynamoDB table as well. Yeah, we could see here it has created the DynamoDB table as part of the claim creation. Okay, now let us delete the claim which we created. qctl delete claim namodb -s3 claim. Then we need to specify the namespace. So now the claim has been successfully deleted. Let's go and validate that in the UI. So we could see that the table has been successfully deleted. So let's go and check the S3 bucket as well. We could see that the bucket also has been successfully deleted. In this demo, we have seen how to create the S3 bucket and DynamoDB together as a composition in AWS using the Crossplane Composition. So in the process, we created a composition and then the composite resource definition, as well as we created the resources using both the composite resource as well as a claim in a specific namespace. And also we have seen when we delete a resource manually from the console, how the resource got recreated by the Crossplane. Also we have seen how to delete the composite resource as well as the claims. If you like this video, please do like, share and subscribe. Thanks for watching the demo.